Advanced Wide Area Network Configuration Part 1, HDLC and PPP. In this nugget, we're going to take a look at the two foundation wide area network protocols that exist out there in the industry, and that is HDLC and PPP. HDLC is designed to be the simplest layer 2 protocol that can tie our wide area networks together. I'm going to show you some options that we can turn on there, and also some debugging that we can do to make sure it's working okay. But by far, the lion's share of this nugget is going to be spent on PPP because there's so much you can do with this industry standard protocol. That's one of the huge advantages that it offers. And I'd like to take you beyond the norm of PPP and show you some of the advanced configuration that you can do. And as always, we'll wrap it up by taking a look at the useful show and debug commands that can give you the most concise and easy to follow output that you'll need when working with these two protocols. But let's start everything off with Cisco HDLC. Now you might be thinking, why do you keep calling it Cisco HDLC? Isn't it just HDLC? Well, it was until Cisco got a hold of it and made it a proprietary protocol. Why'd they do that? Well, because the original HDLC was, frankly, pretty lame. It just provided basic connectivity but had no features whatsoever. So what Cisco did was added a lot of features, and by doing that, they made it a proprietary protocol. First off, they added a keep alive mechanism. Can you believe it? The original HDLC had no idea if a line was up or down. It just tried to communicate, and if it got there, great. They also added a feature called SLARP. I'm sure many of you have heard of it before. This is a way that a Cisco router on boot up can start this auto install, find a TFTP server, get its configuration, and start up without an administrator doing a thing. However, to do that, it has to get an IP address, and that's what SLARP does. It tries to detect what's going on the line, what IP addresses are out there, and it will assign itself one if necessary. From there, they added stack compression. HDLC originally didn't support any type of compression at all, and they added this stack compression, which is really good, but pretty processor heavy. And finally, they increased the performance of what the original HDLC standard was. The beauty of this protocol is, I always think of it as the net buoy of wide area networks. It has just the tiniest little header, 7 to 12 bytes, so it's very efficient when it's communicating across the WAN. And I'm sure many of you remember the good old Windows net buoy protocol. It worked, and it worked fast, as long as you didn't need that many features from it. So that's where Cisco's HDLC came from and why it's proprietary. Truth be told, everybody made it proprietary. Everybody that supports HDLC realized that the industry standard just isn't going to cut it. So just about any vendor that throws routers out on the market is going to have their own proprietary version of HDLC. The beauty of HDLC is in its simplicity. It's so simple we can cut straight to the chase and get into the configuration. I've set up a simple topology on the screen. We have two routers that are connecting using HDLC. The IP addresses I've already set up, and I'm emulating these LANs using loopback interfaces. We have the DCE and DTE side, so we will need to set a clock rate. And I have two goals. One, I need to configure HDLC communication, which shouldn't be too difficult because that's the default encapsulation on any serial interface. And number two, I'm going to go beyond that, enable stack compression to get some efficiency out of the line. And I'm going to show some debug and show commands that can be helpful to diagnose any problems that you can have on the way through, although there's not too many problems you can have with HDLC. So let's jump into it. I'll bring up the configuration window. And I'll just do a show IP interface brief because I just want to make sure everything is as it appears. Sure enough, there's our serial 0/1 IP address right on the screen. I want to make sure that that's the DCE side. So let's do a show controllers serial 0/1, and sure enough, there's the DCE cable. It detects being plugged in there. I don't see a clock rate set, so we'll have to do that. I'll get into interface serial 0/1 and type in clock rate. Let's go ahead and set it to 64,000 bits per second. And guys, I'm trying to think of a more config to throw on there, but since HDLC is on by default, I can just do a no shut. And the best verification command you can do is a show interface serial. Let's do 0/1 and verify that, sure enough, encapsulation is set to HDLC in case somebody had changed it beyond. I'm going to jump over to router 2. And by the way, I forgot to mention, I did turn on EIGRP routing. So these two should learn about each other's LAN interfaces once these interfaces come up as well. Router 2, I'll just do a no shut. And that should bring up the link between the two connections. Now, I'll see it turned to up, and I should be able now at this point to ping 172.16.1.1, which is this interface over on router 1 from router 2. Hit enter, and we have success. I'll do a show IP route, and we should be, learning about that route via EIGRP so we can see beyond it. Let's turn on stack compression. Boss wants to make that link a little more efficient and sacrifice some processor cycles. So we can type in compress, and the only option we have is stack. Only built-in algorithm that Cisco gave us for HDLC, which was even beyond the industry standard. I have effectively taken down the WAN link. Why? Because one side is compressing packets while the other side is not. So, sure enough, I cannot ping between the two at this point. Let me jump over to router 1, enable stack compression. And at this point, I now should be able to ping between the two using compressed packets. Good. Life is good. All right. Well, that's the basic setup of HDLC. Let me show you my favorite debug command for this. It is debug serial interfaces, or interface. When you type this, it actually will watch the keep alives that Cisco built into HDLC. Remember I said it made it proprietary? So you can see if they are being missed. If HDLC misses 3 keep alives, the whole link will be declared down. So 3 of these messages need to go by before it will detect the line as being down. Let me explain this a little bit. You see, HDLC sequence number, is what it stands for, is 8. That is the sequence number that you are sending to the other side. That's your current sequence number that you believe it should be. Mine seen is what the other side, meaning in this case, router 2, is acknowledging back to you. So they are getting your sequence number and acknowledging it. Your seen is 9. This is the sequence number that the other side has. So you are sending a sequence number and it's being acknowledged. The other side is sending a sequence number and you are acknowledging it back over there. So if we jumped over to router 2, we would see this kind of mirrored configuration that you'll be able to see. So you'll be able to see when and if packets are being dropped or lost between that link. And again, up to 3 keep alives before that link will go down. I'll go ahead and turn that one off. That is the handiest debug, and really that's all there is to HDLC. The rest of this nugget is going to be spent around what I call the glory of PPP, the glory of the point-to-point protocol, which is truly an awesome wide area network protocol. And I love to say it's the industry standard, but yet very cool. And the reason I say that is because when you think of an industry standard protocol, you kind of think of, well, it's bland, it's generic, because everybody has to support it. And to get the really cool protocols, you have to use proprietary protocols, like EIGRP is to Cisco. But this breaks the mold. PPP is the industry standard supported everywhere, and it's supported on most connection types. It's supported on synchronous serial connections, point-to-point between them, asynchronous connections when we're connecting with a modem, ISDN connections are primarily using PPP. HISI, the high-speed serial interfaces, use PPP, and DSL is even encapsulating PPP inside of Ethernet frames and inside of ATM. It's amazing technology, but it's supported across the board by most router types, and I like to say it's quite feature-rific. It's just packed with features dealing with authentication, compression, multi-link, where you're combining multiple links together into a single connection type. We have callback capability to where when somebody dials in on a modem, you can call them back for security and even long distance saving purposes. And multi-protocol encapsulation. This is really neat because it allows people to write almost what you call plugins for PPP. You've heard of the Microsoft Management Console, right? Well, on Microsoft Windows, you can actually add these plugins into this management console, which can be written by Microsoft or whoever. Well, with PPP, you have these control protocols And people write plugins for this. For example, you have IPCP. Let me jot that on the board. IPCP is the control protocol for TCP/IP. You have IPXCP, which allows IPX to go through PPP. You even have one called CDP. Oh, if I could write that, CDP-CP, which Cisco has written to allow the Cisco Discovery Protocol to pass over PPP links. So it's very expandable, very extensible, very neat. So let's go ahead and look at the configuration. In this nugget, I'm going to look at the configuration of PPP in two major ways. The configuration on point-to-point serial connection and the configuration considerations that you'll have on modem connections. Now you might be thinking, well, ISDN's a major PPP link. Well, definitely, and it's so major that I decided to dedicate an entire nugget to it. If you want to get into ISDN, definitely look for the nugget specifically related to ISDN because there's so many nuances that exist in the ISDN world that I wanted to make sure that we have the time to go through them all. So in this world, we're going to set up PPP on point-to-point serial connections, which I know many of you may have done before, and you've walked through the base setup, authentication, and compression, but I want to enhance it a little bit and show you something you may not have seen, and that's configuring multi-link point-to-point serial connections. I'm going to have two serial connections in parallel, which means we'll have to create a new logical multi-link interface. It'll be great. And once we've done that, we'll look at the verification and make sure everything's ticking as it should. Then I'll get into the configuration of modem connections. And the goal for that small section will be simple. When you're done there, you'll be able to set up your own internet service provider. Okay, not the whole thing, but at least the segment of the internet service provider that receives calls from users. I mean, there's still a lot of users out there that are using modems to dial up to the internet. And I'll show you how to set up your Cisco router to receive incoming modem connections, and we'll go through the base modem configuration, some of the specific PPP commands that we'll look at for modems, and then we'll also look at how we give those users IP addresses once they've dialed in, either directly from our Cisco router or maybe from an internal DHCP server that's dedicated to managing the pool of IP addresses. So as we begin with our first configuration of setting up point-to-point serial interfaces for PPP, you can see I've enhanced our HDLC example a little bit. I've added an extra interface between these two, and I plan on bundling together these two interfaces using PPP multi-link. That'll require us to create a multi-link interface. That's what I mentioned. Not many people have done that before. And then I already have LAN interfaces configured. EIGRP is running. So as we bring up these WAN links using multi-link PPP, it should start ticking. And once we continue on from there, we'll add our options to PPP. So I'm going to do a quick show IP interfaces brief. And as of right now, serial 0 and serial 1, serial 0/0 and 0/1 are both running HDLC, and they are currently up. That's about all we can see there. And I already have the clock rate set, the loopback interface configured for the LAN connection. Let's go in there and set it up. I'm going to go under interface serial 0, type in encapsulation PPP. Do the same thing for serial 0/1, and what you'll see is those two interfaces will nuke themselves. They're going to go down because the other side is configured for HDLC, and now they're talking different languages. So I want to bundle these together with multi-link PPP. The way I'm going to do it is to exit out here and type in interface multi-link followed by a number. And you can have this be whatever number you want. It's just a logical identifier for that interface. As I have in my topology up there, I'm going to set it to be multi-link 1. I'm then going to type in the IP address. IP address 172.16.1.1. Actually, all logical configuration will be typed under this interface. We're going to put very little under the physical interfaces. We do need to add encapsulation PPP because these multi-link interfaces are kind of generic. They're not specific to a protocol. So we're saying this is a PPP multi-link interface. Now there's a command that a lot of people forget, especially under this multi-link interface. It is multi-link-group followed by a group number. This will be what ties the logical multi-link interface to the physical connections. I'm going to go into interface serial 0/0 and type that same command. interface serial 0/1, same command. I've now linked multi-link 1 to serial 00 and serial 01, so they're all going to be considered part of that same multi-link group. That's one of the biggest commands that you can type in there. From there, for now, before I add any options, I want to get that base configuration up and running. So let's hop on over to router 2. And you can see router 2 is in a similar state, except serial 1 and 2 are down because they're running HDLC. Let's bring them up. I type in encapsulation PPP, encapsulation PPP. So it's on both of those interfaces. I'm going to do the similar multi-link, interface multi-link 1. And by the way, these multi-link interfaces, they're a fairly recent addition to the iOS. So if you have an older version like 12.0 or maybe 11.3, you might not have the option for those multi-link interfaces. I've turned on PPP encapsulation under there. I'm also going to type in multi-link group, put them in 1. Do that to the 2 interfaces, and look what's happening. Ah, look at this. Interface multi-link 1 has changed to up. That's the first time we've seen that message. And the reason why is because we're now adding interfaces to that logical bundle of multi-link 1, and it's now starting to have a good status and starting to run in the background. One thing we forgot to do is go under there and give it an IP address. Interface multi-link 1, looking at the topology, 172.16.1.2 with a 30-bit mask. And at this point, if all is well, we should be able to ping the other side. Let's try it. 172.16.1.1. Ah, I love that. Success. We see it as being successful over to the other side. Let me do a quick show command. Make sure we're using both links. I'm going to type in show PPP multi-link. And what we see there is there's our multi-link bundle. It's been up for 58 seconds. Here are the 2 member links that have been added to this. 2 active links, serial 0 and serial 1. And I know that they're load balancing, or it's utilizing both those links because of this sequence number. It's going to start alternating sequence numbers for each packet it sends across. So it sent sequence 16 across serial 0 and sequence 17 across serial 1. You can guarantee number 18 will go back across serial 0. It's going to load balance back and forth between those, and it reassembles the packet. Here's something not many people know. PPP multi-link completely disassembles and reassembles the packet, so it can be sure to get exact load balancing between those 2 links. See, you don't want to just send one packet on one and one packet on the other, because what if one packet is, 2 bytes in size and the other happens to be 1,500 bytes in size? Well, that's not load balancing. Instead, PPP repackages the packets to where they're exactly identical in size, and then sends them in the perfect load balancing configuration across that. When we get into quality of service in one of the future nuggets, we're going to see how they've actually taken that technology and ripped it out of PPP and applied it to many of the other standards out there. All right, so we've set up PPP multi-link. Let me get back over to my router 1. I'm going to clear the screen off so we can kind of start another section here. Start off on router 1 as we start configuring now authentication. Since this is PPP on a point-to-point connection and we own these links, or quote-unquote own these links between these 2 routers, authentication isn't as necessary on, say, a dial-up connection, but it's still good to get into the practice of it. And let's see how it happens on a multi-link interface. We're sitting on router 1. The first thing that we want to do is get into global config mode and create a user account for router 2. That'll allow it to come over and say, I am router 2 and this is my password. I'll go ahead and do a username R2. It is case sensitive. Password, and we'll just type in, let's use the password of nuggets. Oh, and by the way, all of these encryption options is if you're, say, copy or pasting a config from an encrypted config. Somebody typed in the service password encryption and encrypted everything. That's where you start seeing these options being used if you're cutting and pasting a config back into the router, of course it's going to be encrypted when you paste it. So you need to specify that you are going to type in an encrypted password. 90% of the time for you and I, as we create these configs, we're going to type them in clear text. So we've created the user account. So at this point, let's go into interface serial 0/0 and do some damage. I'm going to turn on PPP authentication chat, which should cause the links to fail because the other side is not set up for that. And sure enough, there we see the status message flying across. If this were a production network, your phone would start to ring now because we have the EIGRP relationship gone down. We're no longer routing. Not a good sign. So let's go over and save the day on router 2. I'm going to hop on over to router 2, global config mode, and create a user account for router 1, password, nuggets. And let's get into interface serial 0, and you can see it's already starting to come up. PPP authentication chat, interface serial 1, same thing, and we should be good to go. At this point, we are now authenticating using CHAP. We can do a debug PPP authentication to actually make sure everything is going on as expected. If we were authenticating. Once we authenticate, it's good to go. But this is, by the way, one of the best commands out there for fixing authentication. Let me do this. We're going to serial 0 and do a shut. Serial 1 shut. Let's shut down those links so that we can actually watch the authentication process happen as I bring up one of them. I'll do a no shut at this point, and that'll bring up serial 1, which is enough to activate the multi-link. And we should see, oh, quick, you all, stop the debug. We see the challenge of CHAP, the response, and in this case, we have a success. Let me tell you the biggest gotcha that I've done. What I'll do, let me do a show run. This killed me. Many different circumstances, and it drove me nuts as to what was going on. When I do a show run, the first thing that we're going to see as this output comes up is the user account that we've created for router 1. Here's the nightmare that I've done in many of my configs. I'll go in and create a user account. Let's create a user account for router 3, as if router 3 existed. Password, and we'll just say nuggets. Do the same. Here's what I've done. I hit space, question mark, to see if there's anything else. I go, oh, okay, that's all I have to do. Enter. Oh, let me tell you what, guys. What just happened there was I created a username of router 3, a password of nuggets, space. There's an invisible space that it actually saved there. You'll never see it in the show run. I mean, obviously, how can you see a space? But when you start doing the authentication, unless you configured nugget space as your password on the other side, it will begin to fail. And of course, since CHAP is completely encrypted, it will show you it's failing in the debug output, but at the same time, it'll look like everything is the same. You just forgot a space on one of those sides. So be very careful when you type in those user accounts so that you don't end up accidentally pushing in a space while using context-sensitive help and saving that user account in there. That's how you make PPP authentication happen. So I want you to imagine this. Imagine you're hungry and you're driving along and you see a McDonald's on the side of the road. You go, great. And you pull into McDonald's, order the Big Mac combo meal. And the guy on the loudspeaker says, would you like to biggie size that, or what is it, giant size or Mondo size? I don't know. And you say, well, how much more is that? And he goes, well, today we're running a special. It's pretty much free. Sweet. Give me the biggie size. Well, in this case, we are going to talk about a topic as I get into the interface multi-link 1 called compression. Essentially, it's like biggie sizing your connection because you're smushing down how much data you're sending across, and it's not much cost at all. Now, it's not completely free, but it's not much cost at all for you. With PPP, you have one of 3 compression algorithms that you can enable. You have stack, predictor, and MPPC. You're going to need to look at your router and figure out what resources do you have most of. Here's the idea. The stack compression, which originally was coined from the old stacker type compression, is a straight compression algorithm, and it is a little bit more CPU, a little more processor intensive than some of the other ones. So if you're looking and you have more processor resources, stack is probably the algorithm you want to use. Now, predictor, on the other hand, is a type of what's called dictionary compression. As the name implies, it tries to predict what type of traffic is going to be sent next and apply a dictionary type of compression to the data. So if it sees an FTP packet, it's going to say, well, you know, I'm pretty sure there's going to be more FTP packets that follow, so I can use the same compression algorithm on all of them. This one is a little easier on your processor, but eats up more memory resources. So if you're looking at your router and you've got a little bit more memory than you have processor, then predictor would probably be the best one. MPPC is used in one circumstance, and that's when you have Microsoft clients. That's the Microsoft point-to-point compression algorithm. So if you have dial-up Microsoft clients or something like that, that's the one you want to use. Just typing in compress followed by what type you want to use, it turns it on. Now there's one other type of compression. It's originally called the Van Jacobson TCP header compression. This one's great because it's a little easier on everything, and it's great if you're sending small packets. Like, let's say you have a telnet connection. Well, the data that you send will be 1 character per packet. T. I just pressed T right there. It sent 1 full packet with a bunch of header and 1 character of data, 1 byte of data. So in that case, it's not really efficient to turn on compression for the whole packet. Instead, I can just compress the header. Header compression can be enabled by just typing in IPTCP header compression. And if you're not too sure if the other side has it on, you want to turn on the passive keyword, which says, if the other side's using it, I'll use it, but otherwise don't use it. That ensures that you can communicate with the other side using TCP header compression. You also have the options for compression connections, which says limit the connections that are using compression to this. So if you don't want to, overwhelm your router with TCP header compression, you can go ahead and say, well, after 10 connections, go ahead and cut it off. But that's how easy it is to enable the TCP header compression. All right, let me show you 2 commands that are not really well known, but I've found useful when I've been configuring TCP. It's the quality ones, the quality settings. There's actually 2 commands, PPP reliability, reliable link. And what this does is it actually turns on error correction at layer 2. Here's the idea. Let's say you've got this link, and maybe it's an unreliable connection. It has a lot of UDP sessions going across. Well, UDP doesn't provide that reliability. So if you want to, you can actually turn on reliable link at layer 2, so it turns on PPP error detection and correction. So it will watch packets and see if they're wrong, and if so, it has a layer of error detection that it can add. The other one is called PPP quality. This one, I don't think I've found many people at all that know about it. Here's what it is. It will watch the connection and literally watch the bytes that are sent and then check with the other side and see if they were received. Based on that data, you can set a percentage of successful traffic. We'll say 75. If it drops below 75% successful traffic, meaning it's sending and receiving and maybe 50% of it gets dropped, well, in that case, it's actually going to drop the connection. This is really useful for modems. We're actually going to talk about those next, because modems can sometimes just have a bad line. I don't know if you've ever had that happen to you when you dial up and it's just a bad line and things are getting dropped. You probably would be better off just disconnecting and redialing. Well, in this case, you can have the Cisco router be a little proactive and say, if I don't get 75% of the packets, go ahead and drop the line and reset it because we need a better connection than that. So that's really how we can set up and configure some of the connection settings on PPP. And let's go ahead and talk about some of the verification commands while we're here. The main command that you can use to verify PPP is just the show interface. I'll do show interface serial 1. Yes, that's one of them in our PPP bundle. And what we see right there is encapsulation PPP We're good to go. Keep alive not set. I actually turned off the keep alive, so that's not a standard one, but keep alives aren't set, so it won't know if the connection goes down. But right here we have LCP open. That's the biggest one that you can see. If LCP is closed, that means it didn't negotiate all the options, be it compression, be it authentication, be it the network control protocols, the upper layer protocols. Something didn't negotiate correctly if the LCP is not open. So LCP open is good, and of course we're using multi-link, so we also see multi-link open. If you want to get all of the info for that PPP connection, for instance, if you want to watch the entire LCP negotiation take place, you can just do a debug PPP negotiation. It's one of the most thorough commands that you can do to watch the PPP negotiation happen. Since we're already running, we're not going to see much, but be careful with this one because it will give you a ton of information. What I usually do is I usually just do the debug. We did this one earlier, PPP authentication, because if any LCP option is going to fail during the negotiation, 90% of the time it's going to be authentication. So you can actually watch the authentication happen, and we just saw that a few moments ago. So those three commands, the show interface, the debug PPP, negotiation, and authentication, those three are the most useful to use when troubleshooting your PPP connections. So with that in mind, let's go ahead and turn our attentions to modems and find out some of the modem-specific commands that we can issue if we have a dial-up connection to our router. All the same settings that we talked about up here with the point-to-point connections will apply to modems. I mean, they're very capable of authentication, compression, multi-link, and all the above. So what I'd like to do is just in this short section after this, talk about some of the modem-specific commands and kind of broaden your mind as to what is possible with modems, because I know many people have abandoned the thought that modems are even useful nowadays. Well, they really are, and now let me show you how. Because of VPN technology, most people aren't running out to invest in a whole new bank of modems for their businesses. They just want to allow people to VPN into their business through the internet connection. But this is where modems are still very useful nowadays. Imagine this router. Imagine it's the core router to your entire network, or an access server that allows you to access all the routers in your network. And there's a network crisis. You happen to be in Hawaii at the time, and you get the phone call. Somebody says, the whole network's down. Help, what's going on? Well, if the network's down, how do you get to it? I mean, the internet connection's down. You can't get to it via the VPN. Well, that's where the modem can save the day. Most administrators will attach a modem to the auxiliary port of their router. That's what that auxiliary port is useful for. Perfect. We can attach a modem to the auxiliary port of the router and assign it to this secret ninja number that nobody knows except us. So all else fails, we can dial into the router no matter what situation is going on with the network. So I've attached a modem to this central router through the auxiliary port. Let me first off familiarize you with this new router that I've pulled out of nowhere. The central router, I've got a serial interface up here that is connected with 172.16.1.1 and a few loopback interfaces. Let's walk through the configuration of a modem interface to allow dial-ins that can get us to the router in case of emergency. And this same strategy can be applied to any modem situation, even a bank of modems that people are dialing into. Maybe you're running a service provider or just dial up service to your business. The first thing I want to do is I want to set up a loopback interface. I get in the habit of this. We'll say it's loopback 3. That is just going to represent my router as a whole. I'm going to say IP address 1.1.1.1, subnet mask of all 255s, just like we do on an access server, to allow us to reach this router and perform reverse telnets to it. Why? Well, because I want to be able to telnet from this router in a reverse sense so I can get to that modem to configure it. In order to do that, I got to figure out what line number the auxiliary port is. Let's get out of this mode and do a show line. And we see the auxiliary port is line 129. So I'll get into line 129 and I'll type in the command initially, transport input and we will type in this case, all. I want to allow all protocols to access the line. You see how the parallels are to configuring this modem are to an access server. And if we wanted to password protect it, we could go ahead and type in login and a password here, but I'm not going to because this is just a base configuration for the auxiliary port. Now, here's an item of note. That auxiliary port, it's designed for situations like this. So the maximum speed it's able to support is 38.4 kilobits per second, or 38,400 bits per second of incoming and outgoing data. It's a slow speed because it's meant for things like a telnet session coming in to rescue the router. I'm also going to type in the command modem inout, because that allows the modem to make inbound and outbound calls, or receive inbound and make outbound calls. Finally, I'm going to type in one more command, modem auto configure, followed by the type of modem, because I'm going to have it, you can either use discovery or type in a type, and I'm going to say, I'm looking at that type, I put that image up there for a reason, because it's a USR underscore Sportster. Now I know. You're probably thinking, wow, where did you get that from? Modem auto configure type, and it says Word. I mean, what do you type there? How did you know to type USR Sportster? Well, inside of this router is a database called the modem cap database. I'm going to type in show modem cap. And what you can see here is that we have a default list of a bunch of modems. We have the Codex 3260. I've never heard of one of those, but I have heard of the US Robotics Courier and Sportster modems. There's the good old Hayes modems days and things like that. This database contains, let me do a show modem cap USR Sportster and finish what I was saying. It contains all the configuration strings for these modems. Oh, I'm going to type in show modem cap question mark. There we go. USR Sportster. Oh, show modem cap is the full word. It won't let me do a shortcut there. Now you can see I can't really talk and type at the same time. And what you can see is all of the configuration that it's going to send to that modem to configure it out of the box. How to set it to factory default, how to set it to auto answer incoming calls, how to set the carrier detect bits on there. All of the configuration for the USR Sportster is right here, so it will now configure that auxiliary port with that by typing in that modem auto configure type USR Sportster. It's going to do that. Truth be told, I could have typed in discovery and it would have discovered, since it's a USR Sportster, what type of modem it is. But it can only discover modems from this list. This is the list of modems that the Cisco router supports. And if you want to, you can actually get into configuring a modem cap entry for your own modem and create a modem named Jeremy modem or custom modem that has all the specific strings. But for now, let's just use one that's in the database. We've now configured it to support that US Robotics Sportster. That's the line configuration mode. That lets us configure the physical aspects to connect to the modem, like the type of modem, the speed of the modem, things like that. We're going to get into interface async 129. That's the same number as line 129 because now we can configure the logical aspects of that modem. And when I say logical, I mean layer 2 and above. Encapsulation PPP is a good one. PPP authentication CHAP is a good one because you don't want people to be able to dial into that modem that you haven't authenticated, and we haven't defined an authentication list, which is essentially what database it's going to use to authenticate those users. Now I'm going to type in a command here that is async mode. There's a lot of modem commands. Async mode followed by dedicated or interactive. This one is key. And the reason why is dedicated, if you type that in, will only allow users to dial through the modem, through the router to reach the internal network. If you're a service provider of some sort, you want to start your own service provider business, or you're a company that's allowing your employees to dial into the network to access email and things like that, you want to use dedicated. that will not let people get into the modem to reach the router. It will just go through the router. Interactive is the one that we want in this case because that one allows you to, you can either go through the router if you want to, or you can now go to the router to configure it in case of this, where we have an emergency and all the connections are down. Now we need to assign an IP address to that port. Let's go ahead and give the modem, because that's what we're really doing. The modem will have the IP address of, we'll just say 192.168.1.10 with a Class C subnet mask. Okay, so we have that modem that has an IP address for people dialing into it. Now, here's the quandary. People are going to be dialing into this. They expect to get an IP address, right? Unless they've configured, like, the Windows 2000 computers to have a static IP address for their modem. They expect to be assigned one via DHCP or something of that sort. Well, here's how we can do that. If we have a user dialing up and they need to be assigned an IP address, we can use one of two methods. We can type in peer default IP address, and we can literally type in the IP address for that user. And I can say when somebody dials in, I will give them 192.168.1.11. That will be the IP address that I give them. And in this case, that would probably be the preferred method that I want to use because I only expect one person to be dialing in at a time. It's only one modem. But if you wanted to get a little more advanced, what you could do is type in peer default IP address pool followed by a pool name. And you could actually create an IP address pool. So let's do that. Let's say I want to have a pool named emergency. Now I need to go back out to global config mode, and this is one of the simplest ways to make your router a DHCP server. I can type in IP local pool followed by the pool name, which was emergency, and then I get to type in the IP addresses that it's going to hand out. 192.168.1.11 up to 192.168.1.12. It'll hand out a pool of 2 IP addresses out that emergency pool or the emergency port. Okay. Now you saw a couple other options in there. I don't want to leave those unaddressed. You had DHCP and DHCP pool. If you wanted this router to be a full DHCP server, you could do that by typing in and getting into the DHCP server configuration mode where you can type in, DNS servers, Win servers, default gateways. You can give it all of the options that it needs. This IP local pool is just a base configuration. The final option is DHCP, and that will allow it to relay a request. It will receive the DHCP request coming in, and it will forward it to a DHCP server inside of your network that will then forward it back out to that user. So you can have an internal DHCP server sending those out as well. Those are a couple of the other options. But in this case, we're just using an emergency pool. I would say this is the easiest way to do it. In my personal opinion, would just be to give it a single IP address to assign for the remote end of the interface. All right. Let me get back to the interface async 129. Get back into that interface configuration mode because there's a few more things that we need to configure. First off, we need to type in the command dialer in-band. Enter. That allows this line, if it needs to dial out. Now, this isn't for incoming calls. This is if it needs to make an outbound call. It will tell it to transmit the digits that it's dialing in the same bandwidth as the normal call. Now that's opposed to an ISDN line where you have like a D channel where all the signaling is separate, and that's what it defaults to. So we need to make sure we type in dialer in band so it knows to send the digits on the same line so the phone company gets them, otherwise it won't. And the final command that I usually type in here is dialer idle timeout and give it a time to disconnect the call. You might say after 60 seconds of idle activity, I want to go ahead and disconnect the call because this is a crucial port. This is my emergency port, and I want to make sure that it's always available. I don't want somebody just sitting there doing nothing and tying up that emergency line. At that point, we have configured a modem to receive and make inbound and outbound calls. Now, we haven't configured any of the outbound interfaces, but that's okay. This is an emergency dial-in port. We haven't configured it to, make outbound calls with phone numbers and things like that, because we don't need to. We just need this to accept inbound calls, and that's what it's doing at this point. Phew, so what have we seen in this nugget? Well, I think I blinked twice and we covered HDLC, which was a very, very base configuration. It's a quick, easy way to get a WAN link up and running. But the vast majority of the chapter was spent on PPP concepts and base configuration. We really just delved right into this. The base configuration is fairly straightforward with the encapsulation PPP. Just about everything else that we did was an advanced style configuration to allow PPP to stand up and dance with multi-link interfaces using modems to connect as backdoors. And of course, we covered the key commands that we can use in PPP and HDLC to verify that they are up and running successfully. I hope this has been informative for you, and I'd like to thank you for viewing.